In the year 1609, Galileo pointed one of the first telescopes ever created up at the heavens, and what he observed sparked a revolution of curiosity that has been central to every single human generation since. Galileo saw mountains and craters on the surface of the moon, the arm of our Milky Way galaxy arching across the sky, and an endless universe riddled with countless stars. The mysteries of outer space were boundless, and the journey towards discovering them had only just begun. Over 400 years later, and our obsession with the enigma that is space has only managed to intensify, fueling many great technological advancements that have made our ever-expanding universe seem smaller and its boundaries closer than ever. On the 25th of December 2021, NASA launched humanity's most powerful telescope yet. More than 30 years in the making, $10 billion spent, a successful launch, 50 intricate outer space deployments, and a distance of over 1.5 million kilometers traveled from Earth, the James Webb Space Telescope has finally delivered its first full-size images of our universe, marking an era of space discovery that promises unique and unprecedented views from across our own solar system to the very heart of the universe. The James Webb Space Telescope, JWST for short, has been designed to look more than 13.5 billion years into the past to study the farthest and oldest regions of space, peering back into the early days of the universe. Its aim is to look at the first galaxies that started forming and emitting light right after the Big Bang. It's no wonder that scientists often refer to telescopes as time machines. In them lies the power to see what our universe once was, and perhaps answer one of humanity's most perplexing existential questions. How did we get here? And right now, Webb is our best chance at finding an answer to that question. However, to fully understand what makes Webb so special, we have to travel back in time to the year 1990, when the Hubble Space Telescope was launched. The Hubble Space Telescope embarked on a mission similar to Webb's. Its purpose, just like Webb's, was to study the universe like it's never been studied before, and to bring us closer to understanding our existence and our place among the stars. Over the past 30 years, Hubble has brought us images of galaxies we never knew existed, star clusters, and nebulae like we've never seen before. These images helped illustrate how in the early days of our universe, just millions of years after the Big Bang, cold clouds of gas and dust evolved into swirling, coalescing galaxies teeming with stars. Sadly, that was just how far Hubble could see. In order to observe how these first galaxies were born, we needed a bigger telescope, one that wasn't just more powerful, but that could also operate in the infrared. So just a few years after Hubble was launched into space, scientists began working on the next big telescope. Today, Webb is 100 times more powerful than Hubble, and its ability to observe infrared light opens up a new universe of possibilities. Literally. Ever since Edwin Hubble discovered that the universe is expanding, we've known that galaxies have been receding at faster and faster speeds. Light from these galaxies is stretched to longer wavelengths as it travels through space, which is why they're only visible through infrared. Hubble, the telescope, is only able to see light on the visible spectrum, which means it's limited in the amount of information it can fetch us about these earliest galaxies. But with Webb, we finally have the ability to observe them. To detect these infrared waves, Webb traveled more than 1.5 million kilometers away from Earth's warm atmosphere, to a very cold region in space that is protected from our planet's infrared radiation. Built into this telescope are huge sun shields as big as the tennis court that protect it from the rays of the sun and help keep its temperature at minus 233 degrees Celsius, so it can be cool enough to detect infrared radiation from the early days of the universe. This is the first time in history of our species that we've been able to look at our universe with such depth and detail. And the first images NASA released on July 12th are proof that we've entered a new space frontier that is bound to bring us closer to understanding our place in this ever-expanding universe. Let's begin our journey back in time with the closest image Webb has taken. This is called the Southern Ring Nebula. It's a planetary nebula in our own Milky Way galaxy, 2,000 light-years away. Despite its name, a planetary nebula doesn't have any planets. The name is simply inspired by its round structure. A nebula is clouds of dust that are thrown out by the explosion of a dying star. You can see enormous clouds of gas thrown out by this red giant in the center of the image. This image utilizes Webb's near-infrared camera, or NIR cam, which looks at the shortest infrared wavelengths. When we switch to its MIRI, or mid-infrared instrument that can observe longer wavelengths, you can actually see that it gives us an unprecedented look into the heart of this nebula. Right here, you can actually see two stars at the center of the system, with the dimmer one being a white dwarf at the tail end of its life, and the brighter one, a red giant, at an earlier stage of its dying process. The pair of stars are locked in each other's orbit in a cosmic embrace, which leads the dimmer star to spray ejected material like a sprinkler, resulting in these jagged rings. Stars are critical to life as we know it. With Webb's powerful mirrors and its ability to peer behind the thickness of gas and dust, we'll be able to study the death of stars like we've never done before. This could give us a greater understanding of the chemicals and the elements that are discharged from stars as they evolve through time, and whether these components are the building blocks that are needed to spawn life as we know it back on Earth. But the birth of stars is just as important as their death. This image of the cosmic cliffs in the Canary Nebula, 7,500 light-years away, offers a breathtaking view of the clouds of gas and dust actively coming together to form new stars. This is one of the most active star-forming regions in our galaxy, a star nursery that could give us tremendous information on this creation process. When we switch to the MIRI once again, you can see the infant stars behind this ethereal cloud of dust. Being able to see what is behind their cosmic clouds is incredibly important when we look at galaxies as a whole. It can enable us to estimate the total mass of stars in a galaxy with more accuracy. Speaking of galaxies, 300 million light-years away lies the tightest galaxy grouping we've ever discovered. These 5 galaxies are called Stephan's Quintet, and they are all bound to crash into each other and eventually merge. Actually, 2 of them are already in the process of doing exactly that. This image of Stephan's Quintet is the largest of Webb's initial images. It might not look like it at first glance, but what you're seeing here is actually a composite of over 1,000 images made up of over 150 million pixels when combined together. Zooming in on any part of this picture will show you hundreds, if not thousands, of galaxies waiting to be discovered. What's even more fascinating is that when we switch to the mid-infrared instrument, we can spot never-before-seen details of Stephan's Quintet. That very bright structure in the uppermost galaxy is actually a supermassive black hole, 24 million times the size of the Sun, and actively increasing in density while emitting more energy than 40 billion suns put together. Just pause and think about that for a moment. These new images provide us with valuable insights into galactic interactions that may have driven galaxy evolution in the early universe. The early universe, Webb's primary mission. This is what is called a deep field image. Deep field is a long-lasting observation into a particular region of space, intended to collect light from the faintest, furthest objects. Peering 4.6 billion years into the past, this image shows the galaxy cluster SMACS 0723 at its center, alongside shimmering stars, warped light trails, and thousands of extremely distant jewel-like galaxies. It's the deepest and sharpest infrared image of the early universe we've had so far. But despite its magnificence, what's most interesting about this deep field is the warped light trails around the galaxy cluster's edges. This galaxy cluster is so massive that it warps space-time, and ultimately the light of stars and galaxies located billions of light-years behind it. This is called gravitational lensing, and acts like a cosmic magnifying glass, bringing the light of galaxies almost 13 light-years away, potentially making them some of the oldest galaxies we've ever observed. Without a doubt, these early images are breathtaking and already showcase the huge capabilities of Webb. But taking pretty pictures isn't the telescope's only superpower. It can also study the atmosphere of planets. For a while now, we've been searching for exoplanets, which are planets outside our solar system, orbiting around a star similar to our Sun. We've discovered about 5,000 of them so far, with our main goal being able to find one that's hospitable to life, and ultimately finding some of that life. When analyzing the atmospheres of exoplanets, we look for elements such as methane, oxygen, or nitrogen, ingredients present in our own atmosphere that could signify the presence of life on these planets. So far, the universe hasn't offered us any signs of life. However, this graph captured by Webb of the hot gas giant exoplanet WASP 96b could be our first step towards locating some extraterrestrials. The observation reveals the presence of a very specific gas molecule, water vapor. While Hubble analyzed numerous exoplanets' atmosphere over the decades and detected water in 2013, Webb offers a more detailed observation and a giant leap forward in tracking down habitable planets beyond Earth. This image is only a glimpse of Webb's massive ability to capture precise atmospheric elements hundreds of light years away. We've always wondered whether life exists beyond Earth, and Webb could be the tool to help us answer this question and change the meaning of our existence forever. The James Webb Space Telescope has only begun its journey, and the road ahead is still long and daunting. Analyzing the universe's origins, understanding the birth and death of stars, discovering distant galaxies, and finding exoplanets are only just the beginning. The truth is, looking more than 13 billion years into the past is bound to raise more questions than we could ever imagine, but it also has the potential to answer questions as well, some of which we've been asking since the days of Galileo, and even new ones we never knew we had. When Galileo raised his telescope to the sky and looked at the craters on the moon, he acted on an almost instinctual human curiosity that has been with us ever since the dawn of time. More than 400 years later, this same curiosity is bringing us even closer to our cosmic background. Earth is only a small stage in the cosmic arena, and with the beginning of a new era in space discovery, we now know that more than we ever did before. There is no doubt that in the upcoming years, Webb will bring the universe even closer to us and help us know more about the reality of our cosmic existence. So whenever you find yourself looking up at the night sky and its beautiful stars, remember, somewhere, something incredible is waiting to be known.